I find it fitting as we go into the double digits of the Contextual Electronics podcast that we talk to Timon, who is kind of a great combination of a lot of the themes that we've already talked about. So Timon is a self-taught electronics person who is developing products that are electronics in nature, and then also he's helping me directly with reviewing the bill of materials for the ABC project, which we talked about here before. And he had offered to do this because he has a lot of experience in doing low cost and low volume at the same time, which is not usually things that you hear about, because usually you think high cost, low volume, or low cost, high volume, right? If you're making a lot of a thing, you can make it cheaply. If you're making a few of a thing, usually you're trying to make it, usually you're less concerned about cost because you just understand that there's tooling and setup costs and things like that. So Timon really is useful here, showing me how to make the ABC board a little bit cheaper, and in the process we get to talk about more about the sourcing as a general thing, right? So sourcing is a big part of electronics in general, but in this case it's a thing where it becomes a key component to try and keep the costs down if you're trying to make just a couple of something at a reasonable price. So I hope you enjoy this 10th episode of the Contextual Electronics podcast. I'm excited to bring it to you, and I'm excited to be making more Contextual Electronics podcasts in the future. Thanks for watching. So I'm here with Timon, and we're going to be talking today about low cost and low volume, two things that don't usually go together. Welcome, Timon. How you doing?
Thank you. Thank you for having me. I'm doing good.
It's good to have you here. We know each other from Twitter and from Hackaday Super Conference and other in real life and online events. And you are quite a prolific producer of online stuff. And I assume
Thank
that
you.
on the other side of the screen, there's some atoms to go along with the bits. So, what kind of stuff are you like building?
When I started out, I was just also fiddling around with sensors and stuff, and I started out with Arduino and things like that. So just experimenting with stuff. But the more I got into like the professional bits and prototyping and software, I kind of delved more into like a product design approach for everything. So I noticed that every time I would start a project, I would think about how to make it, how to produce it, maybe how to add like something mechanical around it, not just electronics. And this evolved even more and more. So I'm very interested in the whole like process from like start to ending, like from coming up with an idea, like what am I missing for myself, what I want to have in the world, and then bringing that all the way to like production. And then also I'm starting to find marketing interesting, which was never the case before. So,
No, he has a sickness, folks. He's in it deep. He's in it deep now. Yeah, I mean, and some of this comes from your experiments, which we can talk about here as well. So you had done the Pi Unora, and this started as an experiment with the CM4, which is the new Raspberry Pi compute module, but it actually it is becoming a thing. It's becoming a product. Is that right?
Yeah, that's true. So I've always been working with the Pi since it came out. That's actually how I got into Linux. It's just experimenting with the first Pi, and I've did some work with the previous compute modules, but didn't really have a use case for these. Mostly because of like the performance cost kind of thing. And with the compute module 4, that was really interesting because it's now this really powerful quad-core ARM processor that can do some serious things that most like a phone, like it's a modern phone kind of power thing. And I just ordered some before and wanted to do something with it. I didn't know yet what. I just wanted to like do something, experiment with it, see what you can do with that. And I thought it would be cool to show. So the initial motivation for that board that I did there, like this milled PCB, was to show people how, well, to some degree, easy it can be to work with these high-speed signals, or like how you should not be afraid of them.
Yeah, it's a great point. I mean, because honestly, it's very intimidating at the beginning. Like you're seeing matched impedance traces. That HDMI kind of feels like magic. Like high speed high-speed displays look like magic. And so yeah, I think this was a great example of like being able to just make it, to show that it's a very pliant platform, that it, it's very forgiving for a milled PCB even. And so that's great, a great
sure.
example, I think.
So I've only learned about that a couple of years ago with my tablet project. I started to like try to figure out like what do I have to do to make this high speed stuff work, because then you look at like the board house and then look, okay, impedance matching is something that comes up quickly if you Google around, and then you look for impedance match PCBs, impedance controlled PCBs, and they cost like a couple $100, and you're like, oh wow, I can like this doesn't really work for you as a hobby. You feel you don't want to spend that much money on just experimenting. So I wanted to show that you can get away with a lot of improper things. So I mean, this is basically the worst case you can have for a high-speed sickness like that. There's no
Well,
ground layer under that.
it's a nicely
So
milled PCB, though. I mean, like,
thank you. Yeah, that's this little PCB mill. I did that.
Other mill, yeah.
Which is a really cool tool to like really rapidly try something out.
Yeah.
So a lot of people thought it was like about showing you can do something cool with mill PCBs. That was actually not the goal there. It's just something, a tool that I have at hand from work. So yeah, it was just about showing, okay, even if you do it really badly, it will probably still work for your hobby project. It will not pass FCC certifications maybe, but
right.
That's maybe not the point. You just want to get your feet wet, and the user on Twitter was actually kind of inspired by that, and he just tried it out and did that and took my design, modified it, and spin his own board, and it worked. And that was wonderful. Like just someone who was previously intimidated by that just tried it out after that. It was cool.
Abusing signal integrity together.
Exactly.
I think that kind of thing is really important. I mean, like so much of, so obviously we talk about learning electronics all the time, like contextual electronics, and so much of it is a head game, right? I mean, it's just like this, looking at all these. I remember sometimes I open these schematics and they're just like these monstrous, scary looking things.
For sure.
And you just, it's like it's very shocking at first, but then you start to break it down. You're like, oh, I recognize that. I recognize that. Oh, small op amp circuit. I can figure out that thing and hooks over here. And when you start to then piece things out and you look at the fundamentals as well, that starts to help you build confidence in a lot of what's going on here. I think this is kind of the real world equivalent of that. It's basically saying like, yeah, there are a lot of concerns, especially if you're trying to make something super reliable, super tolerant to temperature variations and all of the things that can go wrong in the real world. And yet they build a lot of the reliability into the chipset and into the, Ethernet package that retry, and, HDMI that is okay with some weird timing between the pins and stuff like that. So that is really nice. I think this is a public service. That's what I'm trying to say. It was a nice public
Yeah,
service.
thank you. And yeah, for sure, we build on a lot of abstraction there, but that is, I think, a good thing. You could not, like, I was always thinking like you have to learn like first the physics, and then need to know how to make that chip, and like get from zero to like the end thing to actually
Right.
work with that, and that is just not the case.
To bake an apple pie, first you must invent the universe, right?
Exactly.
Yeah, right. I think that's a common trap. I mean, like it's tough to not think I think especially because a lot of traditional education is from first principles, right? For a lot of pedagogical reasons that make sense. You need to learn the physics, you want to learn the math, all that stuff. However, it's super intimidating when you're like, I want to build this really complicated thing. Sometimes the best thing is to fast forward to the end and use this end platform and then work your way back down towards the silicon. I always work personally best top down versus bottom up. And
Absolutely, same for me.
yeah, everybody learns
That's why
differently,
university didn't really work for me.
Yeah, and so and we were talking a little bit before we started recording. Is that you are mostly self-taught? So how's that process been for you?
Yeah, that was so. I started work like my actual background is in motion graphics. So when I left school, I wanted to actually study like film and animation and visual effects kind of stuff. So like work on Hollywood movies. And
the
somehow
silver screen, pretty pictures.
exactly. So I was always like interested in like the compositing part there, and somehow I've gotten a project there when I was working as intern, but kind of doing more than an intern is paid for job. I got into programming and got to like someone showed me Arduino and all that kind of stuff, and that was really interesting for me, and like learning C++. And then I more pivoted to, I think, what is now called today's is a creative technologist, someone who works with technology in creative ways. And from there, so I switched companies, and where I now work at, which is more like prototyping and making concept stuff, exhibitions, all that kind of stuff. And from there, I started to develop more and more into this technical world. And I then tried to briefly study because I thought, okay, I might I felt like I had a lot of gaps in my knowledge and I wanted to fill them. So I tried to I applied for university, and was like a mixture of electronics engineering and IT, though it was 90% electronics at the end. But that was really disappointing, to be honest, because it was, everything is taught from the math. So you first learn the proof of the physical concept, and then the math part to okay, there's a bunch of resistor networks and you calculate them, and sure,
an infinite series of resistors, right?
Yeah, and I get the point of that. It's also think the more I think if you think in universities more of terms of making scientists, that makes sense that you learn first, from first principle and then upwards. So you need the basis to make scientific research. But I already knew where I kind of wanted to go. And there was a lot of stuff that I just was not interested in, and I know I probably will not need. It was interesting to hear about that, but it's kind of frustrating if you already know what you can do, but you learn none of the things that you feel you're missing. So
I do wish I could go back and kind of pick and choose, because some things were super critical now, right? So some of the things I wish I would have been better at, paid more attention to, spent more time on, really dug into, and other things, I just kind of wish I would have.
Some things are super interesting, like digital logic kind of stuff. I found super fascinating, interesting, and still take away something from that. But so I dropped out of that and just continued working and tried to teach myself that stuff. And when I say teach myself, watch, tutorials, read about stuff, read books, and a lot. I read a lot about experiences from other people, how they approach things, and that really helped. So over time, and I tried a lot of things at my day job. I had the opportunity to do more sophisticated things over time, and I could naturally grow into these things.
Did you have mentorship opportunities and people to work with and learn from as well?
That's something I wish I had. So I'm the only electronics focused person, or embedded focused person, and I really wish, especially in the beginning, I had someone I could just ask stuff. That is really helpful.
Yeah.
You can get there without that, but it's much more time consuming.
Someone just pointing you hey, go look up this thing, go check out this book. That kind of thing that's some hard knowledge to figure out. Sometimes it comes down to us Googling, all these different things. You might come across a forum, you might get lucky.
That is the main task I mastered, is being able to Google really quickly. It's best skill to have.
I interviewed Joe Barnard on here a couple episodes ago, and he talked about that as well. I mean, just being able to go and look things up is really important. And we kind of talked about what was it like before that? What was it like before having the world's knowledge at your fingertips? And I think it's now more about synthesizing that knowledge, right? So now all the knowledge is out there. Okay, great. If you can find it, can you take it? Can you put it to use quickly? And it seems like you really have. So that's very impressive.
Thank you.
So let's talk about. So we were saying low cost, low volume. That's kind of the thing, and you've alluded to a little bit here around. You're doing prototyping, but you're also doing displays and showcases, right? You kind of said, what was the word you used?
Exhibitions, for fairs, trade fairs, but also museums, or showrooms. These kind of things where you this meet where physical meets digital kind of stuff, interactive things.
Yeah. So the interesting thing that you and I have been talking about is the fact that, I think a lot of people understand, but maybe if they don't, like the when you're at a low volume, usually you're paying more money just because, that's how vendors who are selling you these things, they need to make more margin at the bottom. But as they sell you more of the thing, they can reduce the piece price. But you found some ways to actually reduce the cost even at low volume. So how has that come about?
Right. So at my day job, we have always the issue that, or also from a hobby project in general, if
Sure.
you want to make something, but they're always like if I approached manufacturers in Germany, there's always a very high starting cost for everything, and they don't take you seriously if you are a small volume because you're not interesting. And
I too have
but
tried to buy connectors from Weidmuller before, like.
so something that I've started to figure out by reading experiences from someone like Bunny Wang,
Mhm.
Andrew Wang, Bunny, like reading his book about producing in China. And I've spent a lot of time researching like how. So it's very clear like everything that's made cheaply is by now done in China. But the question is how can you tap into all of that knowledge and that ecosystem there without, first of all, speaking Chinese,
Mhm.
um, finding someone reliably, like you're on probably the other end of the world, not very close. So how can you establish like a relationship with a factory, or how do you find components? Like all of that was always kind of a mystery to me, and I tried to figure out how how to get into there without like needing to fly there, because that already defeats the
Right.
purpose for me, because very few projects of mine would have the margin to justify a flight into another country just to find,
Right. Even discount
components.
fares are not going to quite cut it.
Exactly.
And so you're talking about
Um,
this book by Bunny, The Essential Guide to Electronics in
Before
Shenzhen.
that, he made a book, I think, a hacker making and breaking hardware or something like that.
Yeah,
Don't have
that's
to.
right.
Um, this is more, I think, a buying guide. The other one is more like a book to read through, which I think is a collection of
Mm.
his blog posts,
Hmm.
where he goes through his experience, like like I think the biggest part that I learned there is about communication
Mm.
and cultural understanding. So he talks a lot about how they made assumptions about certain things, but their manufacturer, coming from a very different background, from a different culture, does not make the same assumption about things. And I think that is the key thing to learn when you try to approach China, or companies in China, is to free yourself a bit from your own assumptions about how stuff is done. So try to not gloss over details you feel are obvious. I
Could you
think
give us
that's
some examples of that?
um, what is a good example there? So just so try to empathize where they are coming from. So China developed, like the electronics industry there developed from a need for very cheap electronics. So for the longest time, most of the customers wanted very, very cheap electronics. So the goal was always to engineer something to make everything super, super cheap. That has some drawbacks. So there is, of course, quality concerns at some point. But certain companies want to make a lot of money, demanded, of course, to compromise quality over price. And that is something I think that is changing, but you still have to keep that in mind, that very often you will be offered to get the process that is the cheapest possible thing, even though something that gives you a much better quality is not much more expensive. So you have to talk about like your requirements. What do you do? And maybe the absolute cheapest thing is not what you want. So you have to tell about, like, give them background about your product. Just don't assume that they're just this faceless company that don't
Mm.
really can understand you. Like, don't expect like they know their stuff, and bring them into your development.
Mm.
And so one thing is just like, I don't know how, like, okay, I have a connector.
Yeah, that's
one
always a good example, I think,
one
because
surface
that's
of that
yeah.
connector should definitely be on the level of the PCB, and it should not have be like raised by a millimeter. It will still work that way, but it's now mechanically a bit more unstable, and can rip off more easily because it misses some support.
Mhm.
Um, it will not fail testing or anything, but maybe that's something that will fail later on because that USB port is maybe abused a lot in the environment it's going to be used in.
Mhm.
So that's something you just have to communicate and make sure, okay, please make sure that these critical parts that I have, that they are in the way I want them to be in. And it's not always very clear what you should talk about, but just try to, if you know what's important to you, voice these things and don't
Mhm.
just assume everything will be up to whatever you are having in your mind. I think that applies to everything, not just working with China, but there I feel especially because we always have these cultural assumptions. So me as a German I have different assumptions about some stuff as you as American, and someone from China has also different assumptions about things, about how stuff works. And
Mhm.
it's important to keep that in mind, and try to talk more than less. So don't just send over some files and please make that for me.
Right, right.
People tend to do that because you have that shopping experience with some manufacturers now where you just upload something and then you get something back and you have never contact with the person.
Right. Yeah, so it's almost like
So
empathy for for someone on the other end who is trying to make this thing and
exactly.
make a customer happy. And like you said, I mean, culturally as well. I mean, they're trying to make a good product, hopefully get a bigger order, that sort of thing. So how do you then, we're talking about low volume as well. So,
Yeah,
as someone
right.
who's often approaching, vendors in China to try and get lower cost, but at low volume, I think there's usually that hope of a higher volume order from someone like you. So how do you then, you are trying to be empathetic to them and understand that they're a manufacturer and that they have these needs, but you're also like, yeah, but I only need like 20. So how do you deal with that?
So right. So the first part is more about I think just to get that quality concern out of the way. Like
Hmm.
you can get really high quality stuff from China.
Hmm.
Just so you don't feel. I feel a lot of people are scared when they hear the word manufactured in China. Still, that this is you know has a connotation of bad quality. That is not the
Hmm.
case anymore. These you go there because they have know-how.
Hmm.
Okay, the next part. How do you find someone who is willing to work with you with low volume? And that is something I think only happened in the past couple of years, really. We've probably most of you have seen that PCB prices have come down a
Yeah,
lot.
to say the least. Yeah, I think that's yeah.
um, and a lot of that, from my knowledge, has to do with how like a lot of machines that have been used before are now obsolete because we now have like smartphones that have so much more demand for accuracy and a lot of high-end machines are now not really usable anymore for like the big customers. So they trickle down to people who like me, um, who need certain quality and volume, but can't really afford high starting costs or high volumes. So there have been now a lot of companies. So you have the PCB manufacturers, but the same is true now for taking place, PCBA, and you get a lot of full service contract manufacturers now that are set up to work with someone that is more in the prototyping area, that are totally fine with just making two things for you,
Hmm.
which I've done quite a lot of times. It will still then cost you two,
Sure.
$300 maybe if you just want two, but the starting costs for these things have come down to 40, 50, 100 euros or so, because they are set up for a lot of customers that want a little.
Hmm.
That just this is possible to do. You just need enough customers to sustain that and have be set up for that. So they are not set up for making a million things. They can't do
Right.
that.
Right. So their workflow is to handle the small orders, to be able to turn things around quickly. without
Exactly.
setting up a huge machine. They might even just be hand placing some certain things and putting the other
Yeah,
things
so
in the machine.
through-hole is often still hand-placed
Yeah.
for lower volume, but they have these really high-end SMT pick-and-place machines, and so that is definitely a good rule of thumb. Try to go as much with SMD as possible, because that is much easier to handle for them. So that is one part. So you can get very cheap PCBs and quite cheap placement in China. So there are several different places you can. There is PCBWay, there's Seed Studio. These are more well-known brands that are more Western-facing with like very good websites. But you can also find smaller companies where you still just talk via email.
I was gonna say
Alibaba is a
they
very
email
good.
me quite often to see if I do have.
Yeah, or just be on Twitter. Yeah, they will find you.
Yeah, I don't usually take them up on it though.
That's again like where this cultural understanding comes in. So English is not the first language. So just because someone has a little bit of a weird English, that doesn't have to say much.
Yeah,
But
this is
what you
more.
should,
I don't usually buy anything that people like try and sell me directly. You
I
know what I
get
mean?
that.
Yeah.
Definitely be wary if
Yeah.
someone just pushes something on you. But I found out that it's not always a good indicator for like.
Oh, no doubt. I mean, like
scamming
they're
things.
trying to, they're just trying to make a living like everyone else, right? It's just like trying to find business, and that's one of the avenues. I don't personally agree with it. So,
I found out that my contract manufacturer does the very same
oh
thing.
yeah,
I just
yeah.
didn't find them via these spammy
Mm-hmm.
advertisements. But
Right.
yeah, anyway. So what do I want to say?
You were talking about the various, PCBA is coming down so much, and
Yeah.
that's obviously
So
impacted a lot of things. It's obviously available to
right. So you can
a lot more
like I
people
want
now.
to name some places where you can find them. So Alibaba is a very good place to find manufacturers in general. So if you don't speak Chinese, usually manufacturers have profiles there, and they have like one or two people that speak English more or less well, and they will be like the communication partner between you and their engineers. And that's a good place to, if you need something more specialized. I think PCBA is very mainstream, so you will find a lot of places that are more approachable from websites and stuff like that. But if you need more specialized things, whatever that may be, laser cutting, machining, um, websites like Alibaba are a good place to start to like just get in contact with people, and just get a lot of quotes. That's also important. Don't, even if the first quote maybe sounds good, always compare prices and always compare communication. You will always find that some companies will answer to your request quite differently. Someone will just immediately reply with a quote and nothing else. Someone else might reply with a quote and a note that they found that this and this feature of your design might be problematic and might need some changes. That is a very good sign that that company is working with you and is trying to make the best product for you, and is very communicative about
Right.
like,
Empathy's coming back the other way. It sounds like.
yeah.
Yeah.
So
They
that's
want
always
they
a good
want you to
sign.
succeed and that sort of thing. Yeah. No, that's great. I mean, I've been reaching out, doing that with more as well, and it does definitely help. I mean, you can get some custom things that you didn't think would ever be customized, and just all you got to do is
Totally.
ask.
And all of that, like this focus on prototyping stuff, that any part of the industry has usually some companies that specialize in that. So you can even get 3D printing, CNC machining can be quite cheap, even in the quantity of 10. That's something I think to keep in mind, that they're very good at that, and they know how to do something quickly. And that's why they can offer these low prices. It's not really anymore because of lower wages necessarily, but just we all of the
Efficiencies in the
know-how is
marketplace.
now like really
Yeah.
concentrated in this spot that is Shenzhen.
Hmm. Yeah, that's great.
So so the manufacturer is, I think, the first really important part, and it's important that you build a relationship. If you just want to do one thing, find someone who's doing that in a more public and broad way, and order there. That's fine. If you're interested in the long term thing, and you have to do that very regularly, it's always a good idea to start making relationships and find a manufacturer that works for you and keep working with them. Um, because that builds trust, and they will try to not lose you as a customer. And I think that's important to also do that relationship building. And I think for when it comes to like low cost, another very important part is of course components, and that was also a big learning for me, that when you start out with PCB design, you go to Mouser and DigiKey, and you find then out that component from Molex cost you like €2 per piece, which
Yeah.
sounds maybe at first fine, but if you then think about like all of the BOM parts that you have, and all of a sudden you're at like €80 for your small board, and
Right. And then you have margins that you have to put in on top,
yeah, and all of a sudden your product
rule
costs
of
€300.
4x, and yeah, exactly. Yeah,
Yeah.
it gets up there.
And one thing to learn there from me was that most of these manufacturers on Mouser, or like let's call them the Western manufacturers, and it also includes Japan, of course, but most of the low cost manufacturers are again in China. And all of these other manufacturers like Molex and stuff, they have specialized in a more like in the automotive industry and in industries that are higher paying, and they have stopped competing on cost. So if you're like all of the things that I do are more in the realm of like consumer electronics, in terms of like reliability. I don't need something that can withstand 125 degrees. You can still get industrial grade components from China, but like just to make the point that I'm not the industry these manufacturers are targeting, and the manufacturers that target my applications are usually not stocked on Mouser or DigiKey or most of these distributors. So the next part is finding the suitable components from these Chinese manufacturers, which has been quite hard in the past, but has been made more easily now with like distributors like LCSC, which is like let's call it a Chinese DigiKey. But also Alibaba now has a lot of manufacturers listed that sell you components, and most of the time you find pin compatible parts even. And there, like all of a sudden, your €2 parts cost only 5 cents.
Sure.
And that is really the key to. Sometimes that's not always the good idea. So sometimes you need that very special part. For like the compute module, you will probably want that original Hyros part. But things like a USB connector, you don't want to use the Molex or wood part, but you're totally fine with many of the Chinese brands. And they are often, that doesn't mean that they are bad quality. They're just produced to a different spec, and they might not hold up as long as the other connector. Like I have never made tests like that, but I've taken them apart. That's something I sometimes do. If I'm like unsure if I trust a component, I take the connector apart and look at like how it's made, like how is there like cracks in the molding or something like that. That's something I like to do.
Yeah,
So
no, I think
just
that's important,
test.
and I think having different expectations is obviously a big start there. I mean, we talked about this with the ABC project, and so one thing I like doing is, even if I'm not going, so say I'm going to use a Hiroshi part, like a high density interconnect, like on the Raspberry Pi CM4, or like we use on the, well, I don't have a picture of it here, like we use on the ABC board though for board to board, like low profile board to board connection, like the Raspberry Pi CM4 does. Um, I I still use the Hiroshi, like you said, but I actually was on. I went on LCSC and a couple of the distributors, and what I was really looking for more than anything else was the popularity, right? So, like, can I find like what is the most common pin count on that zero point 0.5 millimeter pitch, connector? And it was the 50 pin. I actually upgraded I went from the 30 to the 50 because I was like, oh well, if I'm going to find the 50 more often, I think that that's actually a higher likelihood than that there might be, you know, similar parts made later, other options out there for a cost down solution in the future. And I think that's, another way to look at things is looking at, it feels like it's so simple to, when the world is your oyster and everything is available, right? You can get any customization you want. That's great. But if you have to wait 12 weeks and pay tooling costs and, or even just pay €2 a part, it's like, yeah, that then you're really paying that price over the life of the thing you're designing.
Yeah, for sure. That's a really good point. Looking at what's a popular variant of the connector or part that you're using. So sometimes, quite often actually, like the 4-pin version of something might be a lot more expensive than the 10-pin version. And
Yeah, right.
if the higher like if the other version can work for you, definitely go for that instead of that. So that's a very good advice there to always look for what's being made a lot.
Yeah. So when you're trying to so now you've designed in something that has options in China. It has, you've also designed in things that have potential drop-ins. What are some other cost down solutions that you have then? So, I mean, we had talked about connectors and stuff like that, and we're actually going to look at the ABC bomb here in a second. But what are some of the? Do you have any other like kind of broad based solutions for costing down solutions?
So maybe one small other thing is, as soon as you start working in China, you also have to deal with importing components that are not made in China. So if you are then still choosing to get something from Mauser, which is very typical, you will have to include these costs of importing, and they can be quite high sometimes, especially with tariff wars going on with certain countries. That can definitely be a factor. So it can
What countries are
sometimes.
those? I haven't heard anything about that in the U.S.
And yeah, that's so that even more of a reason to then find other sources, or maybe a Japanese manufacturer, or find a manufacturer for like some components have many different manufacturers doing the same parts. Like a
Yeah.
USB mux, for example, is something, I don't know what the part number was, but there's a very specific type that is like basically any manufacturer has one of these.
Hmm.
Find someone who stocks in China, for example. It can also help. Like, so it's still like maybe instead of the ST part, you take something from Dias Inc., which have stock in China, for example. So that's something to look out for. That finds stock in China,
Yeah.
even if it's a Western manufacturer.
Got it. Got it. Have you become a expert in reading Chinese data sheets as well? I mean, that's
No,
because sometimes so like there are some parts that are so like people we go through the LCSC on the course and and I've gone through it myself and there's some really cheap parts out there like linear regulators, things that are jelly bean style components, but you're not going to necessarily be able to read the data sheet or past the graphs maybe so
right.
um,
So one way you can
that's the
approach this
trade-off.
is if it's a drop-in compatible, um, work with the original in quotes.
Mm,
At the English data sheet. But I've actually found out that with Google Translate that works really well.
sure. Yeah, as long as it's not like a graphical PDF or something like
If
that,
it's
as
not
long
a
as
really like
yeah.
critical part, so like an LDO, most of the time you find
Hmm.
with the automated translation.
Okay. Have you gotten burned doing this stuff at all?
Not so far, no.
Okay, that's great. Yeah. Uh, I hope you don't.
All right. One more thing. So if you have troubles finding components yourself,
Mhm.
something that if you have like a full service contract manufacturer, what they can do most of the time is find components for you. So you can say this part, I don't care that much about it. If you can find alternatives, that would be great.
Mhm.
And most of the time they will do that. So I don't specify, for example, LEDs or resistors anymore.
Sure. Yep.
I
Yep.
just write down the values and the specs that I need and
Mhm.
get whatever you need, unless it's
Right.
critical.
Right. Yeah. Yeah. So if you have like a tight tolerance feedback resistor on an op amp or something like that, you're going to write that
Exactly.
it's got to be 0.1% or something like that. But other than that, you're like, yeah, 5%, no problem. Just
And
hit
again,
print.
just be clear about that. Like say, okay,
Mhm.
this part is critical. Please do not change that.
Mhm.
Just do that.
Mhm.
The only time, okay, I've been burned once a little bit, and that's where I did not specify that. So they changed like a crystal for a different
Yeah.
part, and that had a different load capacitance, and that didn't work out quite well. But
Yeah.
they apologize for that. Like another thing, do they own up for like fail? If they mess up, do they
Mhm.
try to like push that on you or push it away, or do they just own up to it?
Mhm.
That's something I would definitely look out for because those that own up to their failures are the best to work with.
Yeah, and I would think that would help if you have someone, if you know someone who's worked with people over there that they trust and they've worked with before. That's always having that kind of like recommendation is a great starting place, I think, and a nice introduction to someone who might be able to help you out. So that's really
Yeah, for
good.
sure.
Okay, do you want to take a look at this ABC board if you don't mind?
Yeah,
I would
certainly.
love your help. So I'm gonna share my screen over here. People probably saw me pop it up here by accident right at the beginning. This is just a raw data dump out of. Oh wow, this is a real messy bomb right now. Is this the right one? This is the wrong one. All right, so I'm going to do a quick re-export here because that does not look right. I know that when I had to export this thing, it looked better. So this is the bomb. Yeah, there we go. See, that's all nice and filled in. That's how bomb should look.
Yeah.
Um, so if I look at the bomb, I use
You also had with
KaiBomb.
Google Sheet, I think.
What's that?
You also had a Google Sheet, I think, for your bomb.
Yeah, I need to re-export for it. Yeah, so I'm just going to generate. And then, I sent you a Google Sheet. That's right. Yeah, where was that? That actually was an older thing. So that was a estimate that I had sent you for.
Right.
Let's see if I can find that. Blocks and budget. Yep. Dogs barking in the background. Yeah. So this is, I think, what I sent you. So this was just kind of like a high level, a high level, high level assumption of kind of what everything might cost. Looking at some of the potential quantities and things like that. How low could we go, and that sort of thing. And so this is kind of a good starting point here for some of like the pricing that I got and things like that. So,
Mhm.
for example, I had it was $15 for the 10-piece cost of the BG95. People can go back and watch the Roy Chen episode that I did on the Contextual Electronics podcast with one of the FAUs from QuickTel, BG595 manufacturer there, and so it's $15 just to buy a couple from them, but it could get as low as $8. So that's just early pricing type stuff.
Mhm.
So you'd seen some stuff in here that looked kind of suspect though.
Right. So these part, like, so the BG95, for example, is a good part example that is usually hard to optimize because that is a super specialized part. Only that manufacturer makes them.
Mm-hmm.
You will sometimes you're lucky and you find a reseller that buys a lot of these for maybe another customer and then resell some overstock for like a lower price. That's sometimes something you can find, but these are usually the hardest to optimize. Where I would always start is very basic jelly bean parts. So the SIM card holder, for example, is a very good example. 50 cents for that, for something that is used in a billion
In
devices
production.
every
Yeah,
year.
exactly. Right.
You will find definitely for lower cost. So
Yeah, and so
anything.
this was one actually where I specifically I remember when we were doing this in the course, we were looking at it, and I actually did spec. I don't know if I can find it on here. I did spec in the LCSC as a backup, but I wasn't going to buy it initially. But I checked. Oh, I guess it's not in here now. I checked that this was a pin compatible version. There is a pin compatible version on LCSC, right? And so that being the the main thing that like maybe I'm not buying the LCSC one right now, but I want to be able to in the future and really just looking for something that is a common enough footprint that I could drop in later.
That is, I think, definitely the best approach. If you're able to find something that has multiple vendors for the same footprint, I would always go for that because there's always the case where maybe the cheap manufacturer can't deliver in the time frame you need, and it's at the end will be cheaper to just choose the more expensive part for that one run instead of delaying. So I would always recommend to do that, but if that's not possible, personally, I would look for a Chinese component that generally is like a lot in stock. So that's where I usually go from. Like, what is always really high in stock? Is it like just a couple hundred, or is it like several tens of thousands of pieces in stock? So,
Yep. Okay, cool.
but yeah,
Let's go back to that spreadsheet. Where did it go though? Here we go. So you said the SIM card holder. I think same thing. UFL. Like we had talked a little bit about just kind of connectors in general. You were saying
yeah, exactly.
optimize your connectors first.
So
What
everything
about
is like
RF
electromechanical.
connectors?
I mean, also something that is used in a billion components, billion,
Hmm.
sorry, a lot of products, of course. So anything that is not super specialized, usually you find Jelly Bean parts that work just fine. It depends on your application again. Like,
Hmm.
do you need to like get that extra couple meters out of your range? I don't know. I'm not an RF expert. You know more about that than I do.
And not much
Um,
of that. So yeah, I
test
mean,
your
so
stuff, you know.
yeah, so and the reason I had chosen this, so you see the 2.4 gigahertz antenna here, this was because of size. I was very space constrained,
Mm,
and then I'd used it before, and I think that's another trade off as well. So like this is a Rev A, right? But I think that then as you're starting to do DFM, right, and we're talking about low volume, low cost. Which is kind of a special case, but as you start moving into higher volume, I think that's when you really do start to do these DFM activities, and you say, hey, let's
exactly.
go
Yeah.
and do some testing for 2.4 gigahertz, see how far we can get with it. What are our real specs? Like, can we hit those reliably with a low cost component? That sort of thing. Putting it in a test chamber, making sure it passes FCC. Because once it passes FCC, that is locked in.
The gold standard.
Do not mess with it. Yeah.
Yeah, for sure. I mean, I think for these specialized parts, one thing to consider maybe there with a lower cost production, sometimes batches of parts slightly differ. That is something that can happen.
Hmm.
Just something to be aware of. So if that's something you cannot work with, go with a part where you know that will always be exactly or pretty much exactly the same every time you buy it.
Hmm.
So I had a case where I have a USB-C connector that I always use, and for a couple of months, that was just a slightly different part. I used a different mold. I don't know.
Mm.
It worked just as fine, but
So what was
you
different
know,
about it?
um, I made a little Twitter thread about that where I just like disassembled that, and someone came up to me and showed me the same part, but it was just internally a different like so. The connectors of a connector usually like the gold pads,
Mm.
they're usually in a plastic mold that make up like the main part of the connector, and then you get like the metal casing around that. And
Mm.
that plastic mold was just different.
Mm.
I wouldn't say one was worse or better than the other, but they just it was a slightly different part. It was not the exact same thing, which
Hmm.
did not matter for me at all. But to
Yeah.
some, that might, and I think it's just something to know about. That some manufacturers will just rather give you something that works for you than let you wait.
Yeah.
It's just different priorities there.
Yeah, well, and I think about, I mean, like, I don't think this is unique to, China or really anywhere. I
No,
mean, I
at
think
all.
really when it comes down to manufacturing, if you have, if you are super high spec, just super high volume type of manufacturer, you're going to have a spec and your manufacturers are set to hit it, right? You expect them to hit it, but it is really on you as the company to have incoming quality inspection to say, our
Sure.
manufacturer guaranteed that they did it, but trust but verify, like make sure that like, yeah, they actually, if it's saying that you get 30 microns of gold, you get that instead of the gold flash or whatever the, like, you don't accuse people of, trying to cheap out on you. However, you need to check that everything that comes in your door is hitting your
Yeah,
quality needs. And because,
certainly.
you know, sure, you can maybe have a lawsuit at some point, but nobody wants that. And it's much better to just reject parts before they get onto your boards. That's always the best thing. So like that is, I think, again, that's a high volume type of thing where you have, so many products or so many pieces that you're making that is required, and you have the infrastructure to do that sort of thing. So it's not common, but I think that when you start moving up in those echelons of manufacturing, then it really comes down to you as a company to do that incoming inspection and make sure that all of the stuff that's critical to your board is hitting its specs.
For sure.
Okay, so what about like what about things that when when you start to do designs like this, do you start to actually redesign based on part availability and cost? So like again, just kind of looking down here, I chose this BQ25895, which is a fancy switcher from TI, and TI is the only one who sells it. It's no pin
Yeah.
compatibility. There's no chance that I'm swapping that thing out for any other part. However, the other choice is I could go and design in something different. And so is that when you will make a decision at the beginning and say, well, I'm going to start with something that's low cost?
Usually I do that, yeah. So nowadays, if I know where I want to go with something,
Mm-hmm.
I I usually start to look like if I know I have to like hit a certain price target, for example, then I definitely start looking at the design phase the very first time, even at the prototyping phase, for the component that I could use. Maybe I start like looking at first the API part or something like that. But if that is just not in my price target, then I look for an alternative right from the beginning, because that is one of those things that are hard to, you can't swap that out, so you have to like redesign that section. And that's, unless you have to have another deadline where you have to like really quickly verify some assumptions about your design, then
Mm-hmm.
certainly I go with whatever is like the least resistance to get
Mm-hmm.
there. That's not always the
It's
cheap
a
part. That
loaded that's a
is
loaded term here. It's not always the least resistance in terms of resistance, though.
the least impedance.
That's right.
um, yeah, so if I just have to like get something out in like 2 days, then I will look for what gives me the best resources to get there,
You
and
make
take the
sure the
hit of like
supply chain
redesigning.
has the capacity. You're saying,
Yeah, like whatever I can get the quickest, and that usually is
yeah.
that mouse or a DigiKey.
Mm-hmm.
And but yeah, I think something like these regulators is a good example, because these can be really specialized. So I actually, for this kind of stuff, I personally tend to not like swap that out, because I just don't know that much about power stuff. So I know I can trust TI to have done at least a pretty good job. Maybe some people
Mm-hmm.
disagree there that know more than me, but you know, it, it, I'm more like trigger happy about parts that I know really well. That's like mechanical stuff, or
Mm-hmm. Yeah.
other things where I'm like certain, okay, if I change that part, that will not make a difference whatsoever. Something that is more critical to my design, like the power delivery.
Mm-hmm.
I personally am a bit more cautious, but that doesn't mean you don't get good like regulators from other manufacturers that are cheaper.
Sure. Yeah. Yeah. And
Um,
so this all comes down to this specific part we were choosing because of the power path and because of the, some of the back power capabilities, things like that. It can do
right,
solar. Honestly, so I should talk about this design specifically too. This design is an unconstrained design, right? And that's really, I think, a dangerous spot to be in. Sometimes it's really fun for designing it for a course, let's say, or for a academic exercise, or for building out a platform. But we didn't have a cost target to start with, and so like that is, there's nothing that really focuses the mind like having you must hit
true.
$20. Like like it's like, oh well, I have 30 cents left. I can only put in a part that costs 30 cents or less. So, yeah, we didn't have that, unfortunately. So, being open ended is actually kind of tough. And sometimes in engineering, like we talk about in the course, is like having a constraint is a little bit uh, not easier, because it's not necessarily easy to do it, but it's a different exercise, I think.
Yeah, I mean, and when it comes down to like that is the engineering at the end. You
That's
are
true. Yeah.
figuring something out to a specific constraint, and the cost is also a constraint of your work.
Yeah. Right. Right. Yeah. And the trade off comes in like, so I think what it really comes down to is like, do I really need solar charging capabilities on this thing? It's like, maybe not.
Exactly.
I'm still figuring that out. Like that's kind of one of the things about a prototype going towards a production type of thing. So do I need it? Yeah, probably not, but it's fun.
Yeah, I mean, I think it's a good point. Like, it's especially now as someone who's passionate about these things. Sometimes, oh, that sounds like a cool feature. I want to have that.
Yeah.
Maybe I could need that in the future.
Yeah, exactly.
It's
Right,
really
right. You're
easy
like doing
to,
contortions. You're like, well, what if I needed it over here?
yeah, feature creep is
Yeah.
real, and
Yeah.
it definitely is sometimes good to really rethink what do you really need, and that's something
Mhm.
definitely also a cost saver to like just cut down on features,
Yeah.
and throw out
Right.
that fancy regulator, because in reality you only need 3.3 volts and at 500 milliamps, and can use that jelly bean part
Hmm.
instead.
Yeah, and I think another thing too is these days, integration is like more and more of a thing. So
For sure.
one of the things that we didn't look at in the course, but I kind of wish we looked a little closer, and maybe in the next revision of this board we will. But the the NRF52 840 is not a cheap part on here, but it is kind of the crux of when it's one of the main parts in the design. But it can handle like a bunch of different power inputs, and so like just thinking through like looking at all of the different things that your key components can do and trying to just squeeze as much as you can out of those. That part is, I think, really important because there's so much integration these days. So if you're going to pay a lot for one part, make sure you're getting everything you can out of it, and maybe giving trade-offs then in other things. So then you're just like main part, bunch of cheapo, connectors around it, and then it's just it's. I think the only other thing is then maybe it's a little easier to replicate. Other people, if you really think that you're going to make some design that nobody else can replicate, which is, I think, tenuous at best anyways. But yeah, I think you can start to really reduce costs on things.
Definitely.
Let's see what else is on here. So, I mean, there's other mechanical things. So, like, what about the mechanical mounts? This is not meant to be a dollar sign here. I'm not sure why I did that, but this is the 4881, which is a part from Keystone. So like something like this, where it's a specialized mechanical component. Is this something where you would go and source it and even find like a vendor on Alibaba?
That can definitely sometimes be worth it, because I find these components sometimes to be extremely expensive. Because often it's just, as you say, Keystone is one of those manufacturers who specialize in one of these things, or would. Personally, I found those really, though, to be the hardest to source, because they are not really traditional PCB components sometimes, and are not always. It's always all about finding the right keywords for the components, which is sometimes the big struggle when you research these components yourself, because in China you usually often don't really have a part number for some of these things, especially when it's not about electronics components.
Right.
They just have terms and specifications. So it's like an M3 threaded, 4mm long SMD reflowable spacer.
Right.
But then sometimes your English words are not the ones that they chose to use, because they translated that for some reason. Then it's some other term has like established in the industry that is not immediately clear. So sometimes about like searching around, or just find someone who feels like it's the right manufacturer for these kind of things, but you haven't found the part yet. Just ask them. It's always
so just like
always good
metal
to
spacer
ask.
person. Maybe they're not threaded.
Yeah,
maybe
exactly.
they're not SMT placeable or anything
They
like that.
they make screws. Okay, that's a good starting point. Maybe they have other stuff, or
right. Yeah, so this is for people that are on video. Obviously, we're doing audio and video here, but people that are on video, this is the there's like a threaded spacer, and this is a SMT placeable thing. And the idea is that it can be placed when you're doing pick and place. That's like a lower cost on the assembly side of things, but then that's another trade-off, right? So maybe you could find low cost hand placement of a spacer, or you could get a spacer inserted later, right? Maybe you actually take it all the way back to changing the mechanical design, right? Maybe you're giving up a little bit on convenience in terms of SMT placeable, but you change the entire mechanical construct of the board in order to do that sort of thing.
Yeah, sure. I think definitely a good point there to like think about your mechanical design very early on, because now you have these spaces in there, and maybe your other components are very close to it. It's sometimes hard then to switch to some maybe other solution that is then feels more viable because it's cheaper, or
Yeah. No, I think that kind of design. So again, there was no design requirement here. This is just an interest level, and so it's like, but that kind of thing ripples forward all the way through your design, and it can really have a lot of impacts. Like you said, you can't put parts close to it, or you're usually not going to get smaller parts. You're usually going to get larger parts if you need to replace them. So if you're buying some specialized tiny part, and then you're like, oh no, I have to buy the big one later, you're kind of out of luck. So yeah. What about any other? Yeah, go ahead.
It's one of those things where sometimes it's worth it to also just talk to your manufacturer again, that they're going to do the assembly. They might know some components in that direction. If you have like a hard time finding the exact thing you need to do, like find a partner who can source something for you. That is very valuable.
Yeah. Here's a good example of a part that was, this is just laziness on my part. So this is actually a part that Adafruit sources on DigiKey. It's the 40-pin Raspberry Pi header,
Oh yeah,
$1.50 for a 40-pin female through-hole header. I
that is
don't
actually
think
still
so.
cheap because I think when I last looked for that,
Uh,
at least for the SMD version, I think, or what was the name of the company again that only makes very expensive connectors?
Samtec.
Samtec, exactly.
Yeah.
It was the only other part was a Samtec part, and that was
Yeah.
like $2.50. Yeah,
Yeah. Yeah. They. Yeah, and that's the thing. I think connectors have this huge impact on potential assemblies. So you got to be. I think if you can design around it, then you're really saving yourself for later. I
but
had
yeah.
actually had a thing where I was designing something. I had assumed I had to go. So basically, I was doing. They were 0.1 inch headers or 0.2 or 2.54 millimeter headers, and I had assumed that there was two of them on either side of a board, and I was like, okay, well, they have to be SMT. You can't go through the board like that.
Hmm.
Um, but the cost difference was so crazy that I started actually looking at like, well, maybe I could just do like an offset of like, yeah, so that you're gonna have two, connectors on either side. They're not going to be completely lined up with one another, but that difference would be so. It actually might have been such a cost savings that again, that mechanical assumption that I had may have been wrong. And so actually going back and like checking all of the assumptions and making sure that like, is it actually needed? That could end up saving a lot of money on the actual
Definitely.
manufacturing side of things. Do you find that when you're doing this sort of thing, are you completely ripping anything off? So like, do you just like leave USB off, or do like assemblies that just don't have certain components included?
Um, you mean so like as a optional placement kind of thing? So
Yeah, exactly. Yep.
definitely. So like the what we talked about earlier, like the Payonora,
Hmm.
which I'm now making like into a little product.
Yep. Oh,
Um,
actually, let me while you've got that up there, let me see if I can.
that has some components on the bottom, for example, that
Hmm.
have some extra features that I find are more of a pro feature, like M2, as PCI Express. Also, like you have the more
Yeah.
expensive spacers. These are from Word, I think, camera connector. So um, when I will eventually sell this, I will have the same PCB, but I will sell a version that does not have these bottom components for people who are not interested in PCI Express.
Got it.
So they can save some bucks there.
Got it.
And
The pro version and
the
the
Pro and the
regular
Lite,
version.
yeah.
Yeah.
So
Yeah.
I think it's definitely a good idea to keep that in mind, not just because of the cost for another PCB. You're also more flexible in the production of things. So if, like, all of a sudden, let's say you're selling something, you're selling a couple hundred or something, and one version's all of a sudden is much more popular than the other. It's much easier to just start placing these other components on there or just leaving them off. Rather than ordering more PCBs of that other version. So you have much more flexibility to like react to demand if you work in that way.
Mm, yeah. Yeah. I think that can definitely help. To I think the only real cost there is like carrying costs, right? So like having more parts or having more boards in your inventory, maybe having to buy more stuff up. That's really more overhead to
Yeah, then you have to like
have.
change the whole the SMT line, for example, has to change completely for that other PCB. Everything has
Hmm.
to be set up differently then.
Hmm.
Um, yeah,
Yeah.
definitely something to consider. Like how I think in general also something I try to learn more about is how does my manufacturer work, and that goes for like CNC machining, my pick and placing. Like
Mm,
what do they have to do to manufacture what I made, and make it easy for them, because
yeah.
they will quote you a cheaper price if you are if you work is more producible and they have to do less because there's a lot of things they will do for you behind the scenes and they
Yes.
usually don't tell you about that. And
Hmm. Yeah, I had
yeah.
an idea for a series at one point. I'm sure I've talked about this on the Amp Hour or here or somewhere else, but around like almost like a library. You need like a mental library um, around how things are manufactured. And so one of the examples was like I was watching someone at my workspace, and they were like talking about 3D printing this device that was basically like a, it was like a U-shaped piece of plastic, and they were 3D printing it, right? So you're going back and forth on the whole bottom side, the base of this thing. It's like, so it's in the shape of a U, and the whole bottom is 3D printed back and forth, back and forth, back and forth, back and forth. And so they were talking to one of the mechanical experts there, and he walked them over to this machine. He pulled out a piece of acrylic, and then he turned on the machine, and he bent it, because it's an acrylic heater. It's a 45-degree acrylic heater, and he bent it in about 3 seconds. And he's like, your product is going to cost a 1/20th as much if you do it with the right method versus using that one hammer that you have to hit every nail, in this case 3D printing, versus understanding that there are other manufacturing methodologies out there that are going to get exactly what you need. But if you don't know what that is, if you don't know how to do sheet metal forming, if you don't know how to do all this stuff, it gets really tough. And I think that it's one of those things where it's like, I wouldn't even know where to start Googling for that sort of thing, of like other ways to make U-shaped plastic thing, So
Yeah, for
it's
sure.
like, yeah.
That's definitely something I did because I knew that I was probably missing something. I started out when I'm with mechanical design with 3D printing. Good example. And I wanted to learn more about some of the older, more traditional manufacturing methods with stamping, molding something, and just learn about what is out there. It's really helpful. And sometimes just scrolling through YouTube and just getting recommended some stuff, and you see like this manufacturing process that you have never seen before, and then you research
how
that
it's
a
made.
bit.
How it's made is like magic.
Yeah, exactly. So
Yeah.
just try to look at a lot of stuff and just get into the mental space of like knowing what's out there. It's definitely a very good advice, I think.
Yeah. And I think then also, like, so another anecdote I have about this is, I had 3D printed the only thing I ever patent for. I helped 3D print, and it was god awful terrible. It was really, really bad. But it got us towards the manufacturing thing. It was one of the early ideas that helped to develop this thing. And I just always assumed they were going to 3D print the final thing, but it ended up being machined ABS. That was, so they had a CNC machine, right? It had multiple pieces, but the manufacturing engineers took this 3D model design, they broke it up into the pieces. They knew how things would fit together best, and then they went and machined it, and it was just like so solid and like so nice looking and finished, because they understood how these things fit together. And I think that there's an analogy there too in the electronics space. Some people might go and throw a Raspberry Pi at a low level, like, they want to display just like a simple screen or something like that. Whereas, a veteran of the industry might come and say, well, we can just throw this, one chip at it, this simple screen, start to build up the system design to make it so that it's optimized for the use and optimized for volume and cost and all these other things.
Yeah, definitely. It's interesting to hear that they did it like milling from ABS actually very expensive compared to 3D printing. So it's interesting that they
but this thing,
that.
like, we dropped it like multiple times. It was so solid. And like, so again, this is another anecdote.
If that is the main requirement, for sure.
Yeah. And but it like looked done. So like, to the point where, and I know I've said this anecdote once before online, but like they showed it to like upper management. And they're like, yeah, we want like 20,000 as soon as you can make them. They're like, no, this is a prototype. Like, this was made yesterday, like, and it's just like,
yes,
but it looks that good, like.
It's easy to mistake the prototype for the final product.
I think increasingly so. And I think I think that kind of goes back towards low volume is so much more capable than it used to be. And, and I think that pairing, low volume is great. And I think that it gets a lot of people out of jams and, can show a lot of what's possible. And then there's probably a whole nother episode around just like the DFM process, right? So the design for manufacturing, and taking that 10 of something that you've tried to cost optimize as much as you can. And like you've shown, like, how to actually make it cost optimized at low volume. But then now you're going to 1 million units, right? You're just cranking as much as you can and really optimizing there. So.
Yeah, I think it's definitely also a different thing to make a couple hundred or even a couple thousand of something where there's like 500,000. It's a completely different job.
Yep. Well, that's what's exciting about electronics. So that's why we're going to keep talking about it for the rest of my life, at least.
Yeah, for sure. I love it.
Well, Timo, thanks for so much for joining me here and talking through this bomb and telling us about your background. It's been really great.
Yeah, thank you for having me. It was fun.
Where can people find you online?
They can find me on Twitter under Timonsku, that is Timon and then SKU.
Great.
And sometimes on YouTube, I stream, that is Professor Sparkles. And yeah.
And the MakerCast as well. That's
the
another,
MakerCast is something I've or usually on sometimes in the year. Yeah. And
Great.
fun. I've actually funded the company a week ago. Diet's Delight is the name of that, and I will release a couple products next year, or this year rather, like the Pioneer.
Great. All right. Well, we'll have links to all that stuff. And thanks again for joining us.
Thank you.
So that's a wrap on our 10th episode of the Contextual Electronics Podcast. I really appreciate Timon coming on and helping out with that bomb review and really just talking through low volume, low cost, and trying to optimize. Hopefully you find that useful in your own project. I'm also really excited about the Pioneer. Keep getting that name wrong. I'm really excited about that. I think that's an exciting product, and I think that that's something that shows how you can take a couple of different products that are out in the marketplace, a couple of different ideas, push them together and really find something that really hits that sweet spot of what the market's looking for. And I'm excited to see that come to market and see some of the things that Timon talked about here being put into his product specifically. So I think we're going to see a lot more exciting things for Timon in the future, and I really appreciate him being on the show. That's all for now. If you want to help out this show, you can always go and review us on iTunes. You can share this podcast with your friends. You can tell everyone about it. Or if you're interested, you can always go and sign up for the Contextual Electronics course as well, which is at contextualelectronics.com. Thanks for watching, and we'll see you in future episodes of the Contextual Electronics Podcast.